Hi everyone, welcome to this tutorial on machine learning with Python. In this session, we'll walk step by step through building a simple machine learning model using the famous Iris dataset. My name is Nithya, and by the end of the tutorial, you'll understand how to load data, explore and pre-process it, train a model, and evaluate the model's performance. Okay, so we begin the tutorial with the imports cell. So let's import the libraries that we need for this assignment. So here we see a NumPy and Pandas are libraries useful for handling data. Matplotlib and Seaborn help us visualize patterns and visualize our data using graphs. And scikit-learn, sklearn provides data sets, our Iris data set, pre-processing tools, machine learning algorithms, and evaluation metrics. And these are the building blocks of most machine learning projects. You can see that this import cell is a code cell, as are the rest of these are code cells, and then these are markdown cells. Okay, but all of our code will be in code cells. Yeah. Okay, so now it's time to load the Iris dataset. Next, we load the Iris dataset from scikit-learn. It contains 150 flower samples across 3 species, Setosa, versicolor, and virginica. Each flower is described by 4 features: sepal length, sepal width, petal length, and petal width, which are the columns. We convert the data set into a pandas data frame here, so it's easier to work with and visualize. Great. Now it's time for exploratory data analysis. So before jumping into our modeling, it's critical to explore our data. Here we plot pairwise relationships between the features colored by species, as we can see in this legend here. Notice that some species are more well separated, especially, yeah, so it seems like the Setosa or the blue species consistently is more separate from the other 2 species. So already we can predict that this species will be classified the most accurately separate from the other species because in literally every graph, this group or the Setosa species is just in the data far away from the other 2 species in every pairwise relationship, so between the features. So this gives us insight into how easy or difficult classification might be. I would predict that the Setosa from these graphs that the Setosa species is more it, it's you're able to classify this species the most accurately. That's my prediction. Okay. So now it's time for the train test split, which is a very standard part of machine learning. We split our data into training and test sets. 80% of the data will be used for training, as we see 20% of the data will be for the test set to test our model. And we use the command stratify here to ensure that each species is evenly represented in both sets, which helps us avoid biased results. Okay, now it's time to pre-process the data. And we're going to be using standard scalar for that. And many machine learning algorithms work better when features are on the same scale. Here we use standard scalar to standardize our features so they have a mean of 0 and a standard deviation of 1, which helps make our training faster and more reliable. Great. It's time to train our model. We're using a logistic regression model, which is a simple yet powerful model for classification. And we fit our model on the training data and then use it to predict the species with the test data, which is what's happening here. And then finally, it's time to evaluate our model. Oh my God. So first, we are examining accuracy, the proportion of correct predictions. And then there's some other metrics here, but accuracy is kind of what we're looking to evaluate the most. So as we can see, kind of from our prediction, the Setosa species, which was the blue one, was classified at 100% accuracy by our model. So this is a great model because at least for one species, we have 100% rate of correct classification, which makes sense because the species is very like separate from the rest of the data. But for our other two species, we had a 90% accuracy rate of classifying each of these species, which means that they got confused with each other for some component of the time. But 90% of the time, we were able to accurately classify each of these species, which means that our model did pretty good. Um, there's different ways for evaluating, but right now we can just say that this is a good model because for at least one of our species, we had 100% correct classification with our model. And then for the other two species, it was at 90%, which is pretty good. So yeah, that's it. So we've built and evaluated a machine learning model from scratch using Python. You learned how to explore your data set, pre-process features, train a model, and measure its performance. In future tutorials, we could compare other algorithms like decision trees or random forests to see how accurate those models could classify these species. But thanks for watching and happy coding, students. Hmm.